Hello, AP Statistics students, and welcome to the College Board virtual instruction for AP Statistics. My name is Luke Wilcox. I am an AP Statistics teacher at East Kentwood High School in Kentwood, Michigan. I'd like to start today by just saying happy Friday to everyone. We've had a whole lot of new students that have joined us this week, and I know that Mr. Murphy and myself are thrilled that you all have been joining us here at 2 o'clock every day. And we hope that you will stay with us through the remainder of this AP exam review over the next couple of weeks. So let's jump right into things here. And first of all, make sure that everybody is in the correct place here. This is AP Statistics. As I've already mentioned, my name is Luke Wilcox. And I do want to give you a couple of quick reminders. If you've been with us for the last couple of weeks, you may already know this. If you are brand new, this is some important information for you. The first idea of which is to know that we meet every day from 2 o'clock to 2:45. That's when we go live. We have split up the AP exam review in an interesting way here, and I want to make note of this. We are currently at the end of this week, April 6th through the 10th, and we have been covering units 6 and 7. So today I will finish out unit 6 and 7 with you in today's lesson. And then starting on Monday with Mr. Murphy, we are going to go back to the very beginning of AP Statistics, Unit 1, and we're just going to take you through Units 1 through 5. And remember, for the AP exam for this year only, 2020, Units 1 through 5 and 6 and 7 are contained on this year's AP exam. It is Units 8 and 9 that will not be on the 2020 AP exam. Now, we do know the date now for the AP exam for 2020 is May 22nd. That is our Super Bowl. That is our Stanley Cup. That is what we are preparing for at this point. A couple of reminders to you. If you want to access the lessons and the homework problems that we're doing in these YouTube videos, you can get those at statsmedic.com/YouTube. You can download those as PDFs. They're organized by the date. And finally, one other note here. If you or another student that you know is in need of a device or internet access in order to be able to take that AP exam on May 22nd, there's a place where you can request that technology, and that is cb.org/tech. So if you or someone you know is in need, please let them go to this site, put in their information. The College Board is very committed to making sure that every student has access to technology to be able to take that AP exam on May 22nd. Okay, we are going to start by checking in with the homework problem that Mr. Murphy gave you yesterday, which is going to be a great lead in to what we talk about in today's lesson. So let's jump right in here. It says, when a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's monetary settlement. That settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against the manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it is convinced that more than 5% of the cars of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought the car and ask them if they experienced this defect in their cars. So in the context of this situation, describe a type 1 and a type 2 error and describe consequences of each. Okay, before we can even talk about type 1 and type 2 errors, we need to make sure that we're clear on what the hypotheses would be for the significance test. So let's see if we can identify the null and the alternative hypothesis. Now, from the context of the question, I know that we're dealing with proportions here rather than means, and it sounds to me like they're only going to take one sample. So it is likely that they're going to take that sample and calculate proportion. And so the parameter for the whole population that we're trying to estimate here is a proportion, and it is the true proportion of cars of this make and model that have the defect. right? That's what the firm is trying to estimate when they take their sample of 1,000 people. Now, the null hypothesis says that that percent is 5%, right? And if it's 5%, then the firm doesn't really want to take this case because they're probably not going to make their money on it. But the alternative hypothesis says that the true proportion of cars with a defect is big. It's greater than 5%, in which case they would want to take this case because they'll be able to make some money here. So let's talk about type 1 and type 2 errors. So first of all, the definition of a type 1 error is that the null hypothesis is true, but we've made an error, and the error here would be to decide to reject the null hypothesis. So let's think about what that means in this particular context. So I need to start out with the null hypothesis being true. So the null hypothesis says that the true proportion of cars with the defect is 0.05. It's 5%, right? So the truth is the null hypothesis. Really, the 5% of the cars have the defect, but the firm makes an error. They make a mistake, and they decide that the alternative is true. And the alternative is that the true proportion is greater than 5%. Well, if they thought that the proportion was greater than 5%, then they would take the case, right? So the error that they make here is we're going to say, but the firm takes the case anyway, right? They really shouldn't have taken the case, but they took the case anyway. That's a type 1 error. Now, we also need to make sure that we talk about the consequence of that error. Well, in this particular situation, the firm really shouldn't have taken the case, right? They take the case, they shouldn't have. They are very likely going to lose some money here. They're not going to be able to recover their expenses. So the consequence is that the firm does not recover its expenses. So the firm is going to end up losing some money here. That is a potential consequence if they were to make this particular error. Now that's a type 1 error. Let's now talk about a type 2 error. And the definition for a type 2 error is that now the alternative is actually true, and the mistake now is to fail to reject the null hypothesis. So let's go ahead and put that in the context of the problem. Now we need the alternative hypothesis to be true. In other words, the true proportion of cars with the defect is now greater than 5%, greater than 0.05. But the firm makes a mistake and they go with the null hypothesis, which says that it's only 5%, in which, in that situation, they would not take the case. So the mistake or the error that the firm would make here is, we're going to say, but the firm doesn't take the case. And they really should have. Now, what's the potential consequence of this? Well, they don't lose any money because they didn't take the case, but they are missing the opportunity to have made money. So I'm going to say that the consequence here is that the firm is missing a chance to make some money. Now, if that all came pretty quick to you and you're still a little bit fuzzy about type 1 error and type 2 error, don't worry, that's what today's lesson is all about. So we are going to dig into this idea of type 1 and type 2 error, as well as the idea of power of a significance test. So let me give you the overview, and that means that I'm going to go to my learning targets for the day. And there are going to be 3 of them. And the first one is what we just talked about in that homework problem. We're going to make sure you know how to describe these errors in the context of the problem, think about the consequences of those and how we might impact those potential errors. The second learning target has to do with what's known as the power of the significance test. And then we also want to know how we can increase the power. And we're going to come up with 3 different ways where we can see the power increasing for a significance test. And then the last learning target is a little bit more general. It's to understand the relationship between these 3 things, the type 1 error, type 2 error, and the power. And specifically talking about probabilities of the type 1 and the type 2 error. So I will make sure that we check back in with these learning targets at the end of the lesson today, and we'll try to summarize what we learned for each one of these. Okay, so let's jump right into today's activity. I think you might be able to relate to the particular context here. The question that we are trying to answer today is, do you have senioritis? The senioritis 20 virus. And so here's what the problem says, if you can follow along with me here. It says, a large high school in Michigan is concerned that too many of the seniors have contracted the senioritis 20 virus. The administrators have decided that if more than 30% of the seniors have the virus, they are going to cancel spring break. To make this decision, they will select a random sample of 50 seniors and have them tested. Okay, I have a quick review right at the beginning of this, just to make sure that we know our definitions for the errors and the power. And I've organized it in this nice little chart here. It's a good way of keeping track of things. And here's how it works. If you look on the left-hand side, there is the conclusion, right, based on the sample. And when you do a significance test, like you've done with Mr. Murphy all week, there are only two choices in the end. Either you get a p-value that is small and you reject the null hypothesis, or you get a p-value that's large and you fail to reject the null hypothesis. Those are the only two choices. If we look up here, this is the actual truth. And once again, there are only two possibilities. Either the null hypothesis is true or the alternative hypothesis is true. And so there are four different scenarios that we need to think about here for each one of the four boxes and try to decide first, is that a good decision or did we make an error there? And so I'd like to start in the column where the null hypothesis is true. So let's just assume the null hypothesis is true, and let's think about each one of these decisions and try to decide which one is the correct decision. Well, if the null hypothesis is true, we don't want to be rejecting the null. We want to fail to reject the null. That would be the good decision, right? So when we reject the null, this is a mistake or an error. In fact, this is exactly what a type 1 error is. So go ahead and label that in the top left box there. Now, we said that if we fail to reject the null, that's a good decision. Well, we don't have a specific name for that. So I'm just going to put a big smiley face here because that means we made the good decision, right? Now let's move over to the second column where now the alternative hypothesis is true. And in this case, rejecting the null hypothesis would be the right thing to do. If the alternative is true, we would want to reject the null. So our smiley face goes here. And then the bottom right would be a mistake, right? If we failed to reject the null, and sure enough, that is a type 2 error. Now, we do have a special name for this one in the top right. This particular smiley face that we have here is what's called the power of the significance test. And we're going to talk a little bit more about that at the end of the activity today. But I want to start by thinking about this type 1 error and type 2 error. And so one of the ways to remember the definitions is to know this chart. Right? You can see this chart. The other way that I try to help my students is just with like what I call the short definition. So let's give the short definition of each one of these errors, okay? The short definition of a type 1 error is that the null is true and we've made a mistake. And the mistake here would be to reject the null hypothesis. There's your short definition of a type 1 error. For a type 2 error, now the alternative is true. And we've made the incorrect decision or an error here, and that error is to fail to reject the null. Now, how do you remember this? The way that I remember the short definitions is really all you have to know is that a type 1 error means the null is true, and a type 2 error means that the alternative is true. And that's in the same order that we typically write our hypotheses, right? Null hypothesis first, alternative true. The reason why I think you only need to know that first part of the definition is because you can get the second part of the definition by just thinking about what the error would be. If the null is true, the error would be to reject the null. If the alternative is true, the error would be to fail to reject the null. So the only part you really have to remember is what's actually true for each one of those. For a type 1 error, the null is true. For a type 2 error, the alternative is true. Okay, with that quick review out of the way, I think we are ready to jump into the context here about this high school in Michigan where they've got this senioritis problem and the administrators are going to go take a sample and do a significance test to decide what they want to do about spring break. So we're going to start with the hypotheses here in an alpha level of 0.05. Now, we're definitely in the world of proportions here rather than the world of means. And it is a one sample problem rather than a two sample problem. So the parameter in this case is going to be a proportion and only one. So we're going to say P represents the true proportion of all seniors at this high school with senioritis. Right? That's the parameter that we're trying to estimate for the whole population of all seniors at this school. And the null hypothesis here is going to say that the proportion is 30%. And the administrators are trying to find evidence that the true proportion is greater than 30%, in which case we're in trouble and we need to cancel spring break. So I think it's important to just think for a moment about what these hypotheses actually mean in words. And so for the null hypothesis, if we're saying P equals 0.30, that means that all is safe, right? If 30% have senioritis, that's okay. It's when it's greater than 30% that we're in trouble. So I'm going to say down here for the alternative, danger. That's the dangerous situation. And that's where the administrators are going to decide to cancel spring break. Now, if the null is true and all is safe, they're not going to cancel. So I'm going to add here that they don't cancel spring break. Okay, now that we have our hypotheses clearly defined, we are ready to talk about errors, type 1 error and type 2 error. So let's start with the type 1 error. And remember, for a type 1 error, the short definition is the null is true and we've made a mistake. The mistake would be to reject the null hypothesis. So here's the way I think about it. The null is true, which means this part is true, but we've made the wrong decision. So I'm going to draw an arrow down to the wrong decision here. This is a type 1 error. When the null is true, but we've made the wrong decision and gone with the alternative hypothesis. Now, we do need to be able to put that all into words here in our answer. So let's put that into words, starting with the null hypothesis. All right, the null hypothesis says that the true proportion with senioritis is 0.30, right? The null is true, that the true proportion is 30%, which really means all is safe. But we make a mistake, and the mistake here is they're going to go with the alternative hypothesis. So that means that the administrators are going to carry out the significance test, and they're going to get a p-value that's really small, and they're going to reject the null and because they have convincing evidence for the alternative. So I'm going to say the administrators find convincing evidence for the alternative, and they reject the null. So if they reject the null and they find convincing evidence of the alternative, they are going to cancel spring break. Now, I can only imagine that the seniors at this particular high school would be outraged by such a decision, that the administrators would decide to cancel spring break when they really shouldn't have, right? Really all was safe, but they made the incorrect decision to cancel spring break. And now all of the seniors are completely outraged. Okay, now let's look at the idea of a type 2 error. So quick definition for a type 2 error, remember that the alternative is true, but we've made a mistake, and the mistake would be to fail to reject the null. So once again, let me go back up to my hypotheses. This time the alternative is true, but we've gone with the wrong conclusion here, saying that all is safe. This is the type 2 error. We just have to put that all into words now. So let's start by stating that the alternative hypothesis is true, which says that the true proportion with senioritis is greater than 0.30. right? Greater than 30% with senioritis. This is the danger scenario. So that's the truth. The truth is that we're in a dangerous scenario here, but the administrators are going to make the wrong choice here, and they don't find convincing evidence for the alternative, and they fail to reject H null. So that means we're up here. This is what they decide. They decide not to cancel spring break. So don't cancel spring break. Now, from the perspective of the seniors, they would be completely fine with this error. Even though senioritis is high, they're still allowed to go on spring break. But let's flip our perspective now and think from the perspective of the administrators. It says from the administrator's perspective, which error has more serious consequences? Well, definitely here, type 2 error is the one that the administrator wants to avoid, because that's the case where senioritis is actually very high and it's dangerous, and they still send kids off to spring break, where we know the senioritis is going to get much, much worse. So we're going to say here that the type 2 error is the one with the more serious consequences. And what the reason why is the senioritis is at dangerous levels. But they do not cancel spring break. And we know if that were to happen and all the seniors were to go off to spring break, when they come back, the senioritis will be even worse, right? So the consequence is that senioritis will get even worse. All right, so hopefully that gives you a good idea about how to interpret, how to visualize these ideas of type 1 and type 2 error. But I would like to give you an even better visual of this with some sampling distributions, show you with some graphs here. So let's go ahead and flip to the next page. And I think this will help solidify some of your understanding of the type 1 error and the type 2 error. So here number 3 says, draw a picture of the sampling distribution under the assumption that the null hypothesis is true. Okay, listen, the null hypothesis is true. As a quick reminder, the null says that everything is safe and that the true proportion is 30%, right? That's our null hypothesis there. And we want to draw a picture where the null hypothesis is true. All right, so this picture I'm about to draw is a picture where the null hypothesis is true. And we know that the null hypothesis says that P is 0.30. So I know that has to be the center of the sampling distribution. And we have this normal condition that we can check, which would check the expected number of successes and failures, both of which would be greater than or equal to 10, which is telling me that I'm going to have a relatively normal distribution here. So I'm going to do my best to draw in a normal distribution. And I want to make sure that it's centered at 0.30. So I'm going to be careful here. I want it to be centered about 0.30. So it looks to me like 0.30 is about the center of this normal distribution. Doing my best there to make sure that the center is at 0.30. So there is the sampling distribution under the assumption that the null hypothesis is true. Now let's think about this. The administrators, they go out, they take a sample of 50 seniors, they get the sample proportion back, and they do a whole significance test, and they have to get a p-value. Now, if they go out and they get a sample proportion of, say, 50% when they take their sample, right? Well, that's very, very high, and the test statistic is likely to be very high, and the p-value, which is this little area here, is very likely to be small. And so what would the administrator do in that case? Well, in this case, they would definitely reject the null hypothesis, right? If they had a small p-value. And actually, the p-value maybe could be even a little bit bigger than that, as long as the p-value is less than 5%, right? And so 5% would be this area right here. Now, we can actually figure out what would be the cutoff value, and it turns out the cutoff value is like right here. If you got a p-hat value of about 0.407, anything bigger than that would give you a p-value less than 5%, and you would reject the null hypothesis. Anything less than that, and you would fail to reject the null hypothesis. So let me make this clear in my picture here, that anything to the left of that value, we would fail to reject the null hypothesis. So the green section there is where we would fail to reject the null. The red section is where we would reject the null hypothesis. Now, let me just pause for a second here. If the null hypothesis is true and we reject the null hypothesis, that is a mistake. That is an error. In fact, it is a type 1 error. And so the area that you see represented in red here, it represents the type 1 error. Now the area in green, well, that would be a good decision, which I've been calling smiley face. So I'm just gonna draw in my little smiley face there. That means we made a good decision on that one, right? So the one thing that I want you to take away from this picture is this red region here where we reject the null hypothesis. We know the area of that would be equal to the alpha value of 5%, right? So it turns out that the probability that a significance test makes a type 1 error is just equal to the alpha value, which for us is 5%, 0.05. So you have two parts of that picture. On the left part in green, you have smiley face. On the right side, you have a type 1 error. So what we're talking about in this chart here is where the null hypothesis is true. So where the null hypothesis is true, there are two possibilities, one of which is smiley face, one of which is a type 1 error. And you can see that represented by the green and the red regions in this picture. Now let's move to the second sampling distribution, number 4, which says, suppose the true percent of seniors at this school with senioritis is 50%. Draw a picture of the sampling distribution under the assumption that the alternative hypothesis is true. Okay, now hold on here. The alternative hypothesis on the previous page said that the proportion with senioritis is greater than 30%. But in this problem, they're giving us a specific value for that proportion as 50%. So we're going to write the alternative hypothesis as p equals 0.50, a specific value of the alternative hypothesis, right? So let's see what that picture would look like, where now not the null is true, but the alternative is true. And it's a specific value of the alternative at 50%. Well, now we need 50% to be at the center of our sampling distribution. So once again, I'm going to do my best here to try and draw a normal curve that has a center. Look, I did it again. I need to move it over just a little bit. I need the center of it to be right at about 50%. So put it like right about there and say that 50% is at the center of that sampling distribution, right? So that's when the alternative hypothesis is true. So let's think about that decision that we made up above, where 0.407 was the cutoff value. Anything to the right of it, we rejected the null. Anything to the left of it, we failed to reject the null. Now, let's carry that down to here, and I'm going to write in p hat equals 0.407 here. Now, we know that to the right of it, we are going to reject the null. Well, in the case where the alternative hypothesis is true, rejecting the null is actually the correct decision to make. And so everything to the right of that value over here, this is a good decision. So I'm going to put it in green because it's a good decision, right? The bad decision or the error here would be if we failed to reject the null, and that's going to the left. So now this area going to the left here, this is where we're making the mistake of failing to reject the null. So fail to reject the null is now on the left there. Here is where we reject the null. One of those is a good decision. One of those is a bad decision or an error. And sure enough, if you look at our table back here, we are now in the scenario where the alternative is true. And if it's a good decision, we call it power. And if it's a bad decision, we call it a type 2 error. And so this means that in green, we have what's called the power of the significance test. And in red, we have a type 2 error. So good decision, power, bad decision, type 2 error. Oh, one other thing to recognize here. For this sampling distribution, we know the total area underneath the normal curve is 1. And so there's a relationship now that we see between the type 2 error and the power that if you were to add those two together, they would have to add up to 1. And so the probability of a type 2 error plus the power of a significance test, we know has to add up to 1. And we can see that right in the picture there. Okay, so let's talk about this idea of power, that green region that we see there, which is a good decision when the alternative is true. So in this setting, the power of the administrator's significance test is 0.91, interpret. Okay, so for power, we know that the alternative is true, and we've made the correct decision here, which is to reject the null hypothesis. And we know that's going to happen 91% of the time. So let's just put that into words, all right? So let's start with the alternative hypothesis being true. So we will say if the true proportion with senioritis is 0.50. And you'll notice here that I'm giving the specific value of the alternative. I'm not saying greater than 30%, I'm saying 50%. That's the value that was given to us, right? So if the true proportion with senioritis is 50%, there is a 0.91 probability that the significance test will correctly reject the null hypothesis, right? And find convincing evidence of the alternative. So that's a pretty good chance, 91% chance that if we really are at dangerous levels at this school, there's a 91% chance that the significance test will make the decision, the correct decision here to cancel spring break. Now, I'd like to show you an applet here, which is going to combine these two pictures where the null is true and the alternative is true. We're now going to combine those into the same picture here using this applet. So this applet is, there is a link on the activity here, or you could just certainly follow along with what I have on my computer here. So this applet is going to allow us to see the power represented in a picture format here, okay? So the first thing we need is the null hypothesis. And we know the null hypothesis is 30%. So I can input 30%. And the alternative hypothesis we know is greater than. And display, I'm going to leave that blank for now. The true value of P, that's the alternative. Well, it's already at 50% for us. That's good. The sample size is already at 50. That's good. And the type 1 error, or the alpha, is at 5%. That's all good. And so you can see here, this red distribution is the distribution where the null hypothesis is true. And the blue distribution is the one where the alternative is true, just like we drew in our pictures in the activity. Now, let me start by showing you the type 1 error here. And when I click that, you'll notice this red region right here, which matches with what we have on our paper, right? And we know that the probability of that type 1 error is 5%, which we said is the alpha value. So notice, if I start to increase my alpha value, watch what happens to that red region as I increase alpha. You'll notice that the area is increasing, and sure enough, the probability of the type 1 error is also increasing. I'm all the way up to 9% now. So you can see visually that the probability of a type 1 error is equal to the alpha level. Now let me take that back down to 5%. And now let's talk about the type 2 error. Well, notice the type 2 error is using the distribution where the alternative is true. And this is where we would fail to reject the null hypothesis. So you see that represented in blue, and it actually shows you the probability there as 9%, right? And the power is 91%. So let me go ahead and click power, which is represented by the green region there, okay? And you'll notice that the probability of a type 2 error plus the power is 1, right? Or 100%, which we know because that's all the area underneath that distribution. So you can clearly see the probability of a type 2 error plus the power has to equal 1. Now, I'd like to focus in on this idea of power for the last part of the activity, and that means that we are going to focus in only on the region that is green in this picture here. So I think we should draw this into our notes here. And then let's talk about how we might be able to increase that power. So for our picture here, we're just going to take the two pictures that we have up above and we're going to drop them onto the same picture here. So the red distribution has a peak at 30%. That's where the null is true. And the blue distribution has a peak at 50%. And that's where the alternative hypothesis is true. And specifically now, we're trying to focus in on this idea of power. And the idea of power is this region right here that we're going to represent in green, which you see represented in the applet as being green. And we know, well, currently the power is 91%. So we want to know, are there ways that we could increase the power? Which would be important to the administrators, right? Because if there really is a problem with senioritis at the school, they want to know about it so that they make the right decision and cancel spring break. So the administration wants to increase the power of the test. How could they adjust each of the following factors to increase the power? So let's go back to the applet now. And this is where the applet becomes really powerful. You can see dynamically how things are changing when you change other things within the applet, right? So let me start with the sample size. And you can probably guess what's going to happen here. If you want your significance test to make the correct conclusion at the end, do you think it would be better to have less or more in your sample size? And I hope you say that you would want a higher sample size. So notice what happens when I start to increase my sample size. As I increase the sample size, what's happening to that power? Now I've got power all the way up to 99%, right? So clearly increasing the sample size is going to increase the power. And the two things that are happening, now notice this again, let me go back to 50 and watch what happens as I get a bigger and bigger sample size. What's happening to the distributions is they are getting skinnier, right? So there are less area in the tails. And you'll also know notice this cutoff value is actually moving to the left, which is also increasing our green area there. So number one way that we can increase the power of a test is to just increase the sample size. All right, that's number one. Number two is what can we do to the alpha level? Well, let me go down to the alpha level here and let's look what happens when I increase the alpha level. So watch what happens. Increasing the alpha level. Well, you'll notice that the distributions aren't moving, but this cutoff value where we reject the null hypothesis is moving, and it's moving further and further and left, which is increasing our power. And the reason is because when we move this cutoff value to the left, it's increasing the chances that we would reject the null hypothesis, which, if the alternative is true, is a good decision. That's our power. So it's becoming easier to reject the null, which increases our power. So number two way that you can increase the power is to increase the alpha level. Now, the third way, and this isn't something that we necessarily have control over, but I'd like to think about this alternative value for P, which is 50%. Watch what happens if the alternative value for P is bigger than that. Well, very quickly, the power gets very, very strong, 100%, right? By the time I'm at 0.71. And this seems to make sense, right? If the true proportion of the seniors that have senioritis is 70%, I sure hope our significance test will be able to detect that by rejecting the null hypothesis. So the idea here is that the alternative value is getting farther and farther away from the null value, right? Which is increasing our chances of making a good decision. So that's number three, is to increase the distance between the null and the alternative values in our hypotheses. So let's capture that idea in the last question here in the activity. Sample size, what do we want to do to the sample size? We want to take n and we want to increase it. Okay, alpha level, we decided if we want to increase the power, increase the alpha would increase the chances that we reject the null, which would increase the power. And then for the alternative, we decided the further it was away from the null, the better our chances of making a good decision, the power would be. So I'm going to say farther from the null hypothesis, H null. So those are the three ways where we can impact the power of a significance test. All right, I think we are ready to try and summarize our learning. So this is where I'm going to go back to the 3 learning targets from the beginning of the lesson, and let's just put down some quick notes about what we should get out of each one of those. So starting with learning target number 1. So for learning target number 1, that was for us to understand how to interpret or describe a type 1 error and a type 2 error. So let's capture that idea here, starting with the type 1 error. Okay, the definition for a type 1 error is that the null hypothesis is true, but the test finds convincing evidence for the alternative. Finds convincing evidence for HA, right? That would be an error, right? That the null is true, but the test finds convincing evidence for the alternative. Make an error there. That's type 1. Type 2 error. Remember now the alternative hypothesis is true, but we make an error, and this time the test does not find convincing evidence for the alternative. So the test does not find convincing evidence for HA. So if you're asked to do that in a free response question, you always want to make sure that you do that in the context of the problem there. All right, learning target number 2. For this one, we talked about power and how to interpret power, as well as how do we increase the power of a test. So let's start with the interpretation of the power, all right? Remember, for the power, we were in the second distribution where the alternative is true. So if the alternative is true, and I want to make note here that you don't give the generic alternative, you give the specific value of the alternative. So I'm going to say here, use specific value, right? For us, it was 50% of the seniors had senioritis. There is a, and then this is where you would put whatever your power is. And that is definitely a probability. We want to describe that as a probability of correctly rejecting H null. And what that really means is that we find convincing evidence for HA, right? So notice there that I am using the word probability, and in fact, it's a conditional probability. It's that the condition comes right up front, right? Assuming the null hypothesis is true, or given the, the alternative, given that the alternative is true, it's the probability of correctly rejecting the null hypothesis. That is a conditional probability. Now let's make note of the 3 ways that we talked about where we can increase the power of a significance test, right? We had 3 different ways to do this. Number 1, this is probably the easiest way and the most intuitive, is to increase the sample size. Number 2 was to take that alpha value and increase it. And number 3 was to take the distance between the null and the alternative and make that distance bigger. So the distance between the null and the alternative, make it bigger, increase. And finally, learning target number 3 was to understand the relationship between all 3 of these things that we're talking about. So here were the important things you needed to take away. First of all, the probability of a type 1 error. We know that that is just equal to the significance level alpha. The other thing that we determined was that the probability of a type 2 error added to the power of the significance test has to add up to 1. So if you're given the power, you should be able to find the probability of a type 2 error. If you're given the probability of a type 2 error, you should be able to find the power. I want to make one final note here. It's this idea of increasing the alpha, right? We have the decision to make about what the alpha would be. And let's suppose that we decide to increase alpha. I want to think about what impact that would have on some of these other things here. Well, the first thing we know is that if we increase alpha, the probability of a type 1 error, of course, is going to go up because the probability of a type 1 error is the alpha level. But here's the other thing we decided, that if we increase alpha, that also increases the power. So the power would actually go up. But then go back here and think about it. If the power goes up, what has to happen to the probability of a type 2 error if those two are going to add up to 1? Well, the type 2 error has to go down, right? So the probability of a type 2 error actually goes down. And so the thing I want you to notice here is that when you're trying to decide your alpha level, whether to increase it or decrease it, it's having the opposite effect on the probability of a type 1 error and a type 2 error. And so depending on the consequences of the type 1 error and type 2 error, that might help you make a decision about your alpha level, right? For example, the administrators really didn't want to make a type 2 error, so they might have increased their alpha level in order to decrease the probability of a type 2 error. All right, so there is a check your understanding problem. This is your homework problem for the weekend that will be due on Monday. Mr. Murphy will start his lesson on Monday by taking you through this practice problem. It's also available to download at statsmedic.com/YouTube. So listen, I hope you got something out of today's lesson. If you did, make sure you give me a thumbs up there in YouTube. And I hope that you will join Mr. Murphy on Monday, and I will be back with you all on Tuesday. So have a wonderful weekend.